In this section, we're going to be talking about using 3-axis advanced toolpath methods to assist you in machining a cavity / core mold plate. We have a core mold plate just loaded, which contains various poly surfaces that need to be machined. Now we have some machining operations already loaded in this file, so let's just go over them real quickly. We have a roughing operation and a re-roughing operation to clear material away from the core region, and the re-roughing is a professional configuration toolpath method, and we have some additional re-roughing to get some more material off of the part. And then we have a series of finishing operations. These operations are not required for the professional configuration or advanced 3D machining methods, so we added these to the file beforehand. So we have a horizontal finishing to finish the part from the parting plane up to this height, and then we also have a second horizontal finishing operation to clean up the bottom edges of the core. And then we have a few parallel finishing operations that flow with the geometry, and this is what you want to do as far as your any operation you use on a mold cavity or a mold core. You want the tool to flow with the part geometry, not against it. So we have a parallel finishing operation, and it's going in the X direction, and we are fitting arcs to that tool path. So you see nice blue arc motions all the way down the length of these radial regions. And also we have one in the mid area, parallel finishing with arc fitting. The toolpath's going in the Y direction. And then we have another toolpath going in the Y direction, parallel finishing, as you can see here. And then we added a 2-axis profiling operation just to clean up these flat areas here and here. Okay, but that leaves a lot of areas that still need to be machined, and advanced 3-axis methods or the Pro configuration has the toolpath operations that you need or would want to have to machine this type of mold core. So first off, we're going to machine these surfaces in here, and we're going to use a 3-axis advanced when we're going to use 3D offset pocketing. And 3D offset pocketing, you can consider it like a net that you throw over the part, and the cut offsets are consistently spaced, irregardless of the topology of the part model. So you have a consistent step over in both the X and the Y, and following the contour of your part. So we're going to go ahead and go to the Part Surfaces tab. We're going to use the Select Surfaces button, and we're going to go in and select these surfaces here. Okay, so we got our surfaces selected, and we're going to use the on condition, which means that the tool will go up to the boundary of the curves but not extend past it. So for the tool, we'll use our 1/16 inch ball mill, and clearance plane, feeds and speeds, they're not irrelevant to what we're talking about here. So we'll go straight to the cut parameters tab. We have a tolerance set, and we're going to use a mixed cut direction. We're going to start cutting on the inside, which means it's going to start in the middle of this area and work its way out. And then for a step over, let's go 0.01, say, for practical purposes, and for the entry and exit, we'll leave that as linear entries and a linear exit. So let's generate that. Okay, let's zoom in on that. what you see here is a constant 3D step over that encompasses the surfaces that you selected and follows the contour of the part. Now the reason it didn't drop all the way down to here is because we had the 2 option selected. So if you go to the top view, you'll see that it lines up perfectly with the edges of the geometry that we selected. Okay, so the next area, we have some additional similar areas in this region here. So we're just going to clone this operation. We'll open it up. We'll remove those surfaces, and we'll select these surfaces here. Okay, and we'll generate. Again, we have a consistent 3D step over following the contour shape of these surfaces. And this operation is only available again in the Pro or 3-axis advanced configuration of the product. So we got some additional areas here that we could use this on. So let's go ahead and clone this again. And we'll open it up, and we'll remove our part surfaces and select these surfaces here. And hit enter and generate. So again, you see, if we look at the top view, we have perfect coverage of these surface areas, and the toolpath is a constant 3D step over, and it follows the contour of these surfaces. Okay, so we got some other areas that we need to machine. Back in this area, looks like we could use the 3D offset pocketing here as well. Let's go ahead and clone that. Remove the surfaces and select these surfaces here. Okay, and then we'll generate. Again, we have a nice 3D step over following the contours of these surfaces, and you notice that it doesn't continue all the way down to the parting plane. That's why we have the horizontal finishing that's going to take care of these areas here. So if you look in the top view, you'll see that it covers these areas on the part completely. Okay, so let's go to this view here, and let's show you some other advanced 3-axis methods that we can use on this part. Let's go to 3-axis advanced, and let's do the between two curves machining. That's right here. And what this does is this lays down a constant 3D step over between two curves of the model. And we will select some additional curves. Let's try those and pick generate. Okay, so we have a constant 3D step over that's the toolpath morphs between this curve and this curve here, following the geometry of the part. So let's do that again. Let's clone that, and this time we'll remove those, and we will use this curve and this curve. We'll generate. So that takes a nice draping surface down across that region. And also let's go ahead and do a curve machining method, and this is a advanced 3-axis method as well. We're going to go to 3-axis advanced, and we're going to select curve machining. And what this does is it machines along a given curve, and you can machine on the curve and on both sides of the curve. So let's go ahead and do this by curve edges. We're going to go ahead and select this here, and I'll work our way down. And work our way up here. Okay, so there's our curve regions selected, and let's go ahead and go to our tool. We'll select the ball mill. For cut parameters, we can machine on the curve, along the curve, or across the curve. So in this example, we'll go along the curve, and we'll set a cutting bandwidth of 0.1. This is the width of the total cut. So in this 0.1, you can, so we're going to, along this cutting bandwidth, we're going to step over a distance of 0.02. Okay, so let's generate this and see how it looks. Okay, so you got a three-dimensional toolpath that's following the selected curves that we created, and it steps over 10 thousandths or 20 thousandths, and there's a total bandwidth of 0.1 on either side. So you can use this to do touch-ups in certain areas of the part, and all you need is a curve. And you can do this, you don't have to have a closed curve. You can remove those and just have one single curve and generate that. So you can use that for all different kinds of cleanup operations. Anywhere that you have an edge that you can select, you can run a path along that edge to clean it up. Okay, so let's do one more 3-axis advanced method to clean up these bottom edges. I know we had a horizontal finishing here, but we're going to use a pencil trace operation, which creates a toolpath based on the bitangent region of the tool and the part geometry. So if you just come down here and put a profiling operation in there, you will end up cutting more away from your part than you're supposed to. So by using a pencil trace, it will determine where that ball mill can travel in order to be tangent to the part, as well as laying on the parting surface. So let's go ahead and see if we can create one of those. We'll pick 3-axis advance. We'll pick the pencil trace operation, and we'll remove that drive region. And what we're going to do here is we want it to calculate the pencil trace areas inside of the entire part. So we're going to select this offset curve that we already have created, and everything inside of that offset curve will be included in the computation. So let's go to the tool, and we'll use the 1/16 ball mill. And then for clearance cut parameters, we're just going to use a cut directional climb, and we're not going to do multiple cuts. We're going to let it determine one cut to clean up that area. That should be sufficient. For the advanced, we don't need any advanced parameters, and for entry exit, we'll go ahead and leave those as linear entries and linear exits. Let's generate that. Okay, so here you see it calculated a toolpath at the base of the part and the parting plane in order to clean up that area of the model. I hope that helped to give you a better understanding of the benefits of the 3-axis advanced toolpath methods that can be used for machining mold cores and mold cavities.